Hello guys, welcome back to the channel for a new Databricks video. Today we are going to continue with dbt and Databricks. If you watched my previous introductory video about dbt, you will see that I mentioned the most important feature of dbt is the easiness to apply data quality checks and tests. There are many ways to perform data quality checks using dbt. We can either use built-in data quality checks, we can use external packages like dbt expectations, or if that's not enough, we can create our own custom SQL checks. In this video, we will see all the ways of how to perform data quality checks using dbt, but first, let's take a look on the documentation. Let's read the overview for data quality checks. Data tests are assertions you make about your models and other resources in your dbt project. You run dbt test and dbt will tell you if its test in your project passes or fails. Out of the box, we have 4 built-in checks, one for containing not null values, or if we have unique values in a column, or values that have a corresponding value in another model, so for foreign keys and preferential integrity, or have values from a specified list. And here, data tests return a set of failing records. Generic data tests are defined using the test blocks. In particular, they are select statements that seek to grab failing records, one that disprove your assertion. Remember here, we have to use the negative case. So if you assert that a column is unique in a model, the test query selects the duplicates for duplicates. If you assert that a column is never null, the test seeks after nulls. If the data test returns 0 failing records, it passes and your assertion has been validated. There are 2 ways of defining data tests in dbt: a singular data test using SQL query, and the generic data test, which is a parameterized query that accepts arguments from the function that you have defined. It's like a macro. You pass the parameters and you execute the query with these parameters. And we have the singular data test, as we said. Here, this is an example. Here we check if the total amount is less than 0, then the test fails. So remember, it's the negative case. We are seeking for the invalid records. And here you can also use a description, add a description in your YAML if you want, and then we have the generic data test. Here we defined, remember, we use bracket and percentage for the functions, and here we define the function, the test function, not null, and we pass the model and the column name, and here this is the query, that the parameterized query that we can use again and again in different columns. For example, this not null can be used in different columns for validations. And then we end the test. And also here, as we said, there are 4 built-in checks: unique, not null, accepted values, and relationships for referential integrity. This is an example, and also we can store data test failures, very actually convenient. Normally a data test query will calculate failures as part of the execution. If you set the optional store failures flag, the store failures or the store failures as configs, dbt will first save the results to a test query, to a table in the database, and then the query that then you can create the table that calculates the number of failures. And here the new syntax, it's data tests instead of tests. Test is an alias here. dbt still supports tests, but it's better to use data tests. And here in your dbt_project YAML, you can add this configuration if you want to store your failures and then query the failed results and see what went wrong. In our VS Code now, if you remember from the introductory video, we have 3 models. The first one is this one that is selecting data from this big house and sales customer table from the samples dataset that we have in Databricks. And here is the YAML file that we define the columns and all the data quality checks. Then we have the model 2. Again, we are selecting data from another table, and here I showed you how to perform a for loop and use if statements. But let's go first into the YAML and see that in these columns here for customer ID we have not null and unique. So this column should not contain nulls, and if the customer ID should be unique, right? And these checks should actually pass because the customer ID is an ID column and it shouldn't contain null, and everything should be unique. And here for referential integrity we can reference to model 2 based on customer ID. For example, customer ID here can be used as a foreign key in the sales transaction table. We can check if everything is okay regarding this relationship. Then we have first name, we have not null, which it should not fail. We should have a first name for every customer. The uniqueness test here, it should fail because there are many customers that will have the first name. Same for the last name, right? And the gender, as we mentioned here, accepted values is the fourth built-in check. We accept only male or female, for example. So if we want to run this test here, you will see that some of them will fail, some of them will pass. So we can do a dbt test and then -s model 1, and it should run these tests here, see which test passed and which failed. Here in the terminal you can see all the tests that run, and this one passed, so we don't have null values in last name or first name or customer ID. Customer ID is unique indeed, but here, for example, the referential integrity check failed, and if we go into the data you will see that customer IDs do not match between these two tables. Let me switch to Databricks workspace. So here I perform a left join between the sales customer and the sales transaction table based on customer ID, and as you can see in the customers table we have IDs that do not exist in the sales transaction table. So the foreign key here, the check, we can see that we are missing IDs between those tables. And then the next check is about the uniqueness of first name and last name. Both of these tests fail because we have duplicates. And here you can see, for example, failure in relationship model customer ID, and if you check actually here it says the compiled code, so the query that we run, and here this is the compiled query and how it performs the test with for referential integrity. And you can see the same compiled code for the uniqueness of the first name, and you will see basically the SQL syntax of how dbt performs those checks. Now let's actually create a custom singular test using SQL. Underneath the test folder here, so let's create a new file called, for example, test T1 for simplicity, and it will be an SQL file. Let me paste this. So here we are selecting from model 2, we are referring to model 2, and we do a sum of the quantity to check the total quantity per product, and to check if the total quantity is negative, then this test should actually fail, because we shouldn't have total quantity less than 0. Remember, we want to flag the invalid records, not the valid ones. Now, let's run dbt test minus s and then t1, and to run only this test, not all the tests. And here you will see that it's going to run this check here, the singular SQL query, right? It started running test T1 and it passed successfully. Now, if you expand target and you get the compiled code and then expand tests, you will see this here. That's the compiled code. Here it replaced model 1 with model 2 with the full namespace, workspace, demo, model 2, right? So you can see the compiled code under tests. Now let's create a test that would fail and see how that works. So let's create a new SQL file called t2.sql. Let me paste the code, and here we define the severity as well in this specific test. So for this specific test, it should be a warning, it shouldn't be an error. And here we override the original config that we have in the dbt_project, where the severity equals error. So here, if the test fails, the severity should be warning, and we are selecting from the sales customer table, where first name equals Catherine and gender equals female. So this is a valid case because Catherine is a name for a female, so this will return the valid records. So this data quality check will fail because it will return records. Remember, we want the opposite. So let's run it like this, and this should give a warning, not an error, but the test case should fail because we are bringing all the valid records. And remember, when we perform data quality checks, we want the invalid records. We are searching for invalid records. Here it gave a warning. Now the correct test case would be to search for first name Catherine and gender equals male, and that would bring the invalid records. So now this test will pass, and it should pass. Give it a second. Yeah, it's running again. Now it passed the test. The test case is valid because there is no customer with name Catherine and gender male, right? So this is how you can perform data quality checks. Use the negative case. Now it's time to see a generic test, how you can create a generic test that you pass parameters and reuse it wherever you want inside the code. So let's, underneath the test folder, let's create a new folder called generic. And inside generic folder, let's create a new SQL file, for example, key3.sql, and here, let me paste the code. Here we use brackets, percentage symbol, the test, we are using the test function, and here this is the function name, assert not null values SQL. You can name it whatever you like, and here we pass the model and the column name. We are selecting from the model where the column name is null. So, and here we end the test, we close the brackets. And now if we copy that into our model 1 YAML, for example, if you don't want, this is the same check. So if you replace not null with assert not null values SQL, it would bring back the same results because essentially this is the same check, but you can customize and parameterize the function and parameterize your queries and reuse it wherever you like. Now let me run dbt_test select model 1, and again it should fail for last name. Maybe no, it shouldn't fail. This test shouldn't fail. Let's wait. It ran all the tests. As you can see here, assert not null values SQL model 1 for customer ID, the same for first name, the same for last name. So this data quality checks passed, the referential integrity failed as we checked, and the uniqueness for last name and first name also failed, but that was expected. Here you can see though the custom function for the data quality checks that we applied for 3 different columns. Again, if you go into your compiled and see your model, your tests here, under run basically, you can see the models, the schema, and here you will see unique, not null. Yeah, you will see all these data quality checks, and underneath model, yeah, I found it here, assert not null values SQL model 1 customer ID. You will see in the compiled code under models, under model 1, you will see the assertion that we performed for first name, last name, and customer ID. So that's the generic version of how you can create generic tests and reuse the same function again and again in your data quality checks. Moving on, we have external packages that we can use. So if you go into hub.getdbt.com, you will see external packages that you can use. DBT expectations, for example, we have it here. This is how you copy that into your packages.yaml, and if you open GitHub, the documentation, here you will see all the available tests for table shape, for missing values, set and ranges, string matching, multi-column, all these data quality checks, and it has documentation for everything. For example, here, expect column values to be between, and here you provide the minimum value, the max value, all these kind of things. So this is the documentation. You can see everything for every data quality check. The same for the DBT utils package, which has also data quality checks. And here you can see documentation for expression is true. For example, here you will see asserts that the valid expression is true for all records, and you can use expressions and all these kind of things, config, where you specify the columns, etc, etc. So let's see some examples using DBT utils and DBT expectations. In your packages.yaml, so let's add, I have already added in the previous video, in the introductory video, we added DBT utils. Now we add this DBT expectations package, and then what we have to do is actually run DBT deps command to install the dependencies here. Let's wait for it to finish. It will install all the necessary packages to install DBT expectations. After that, installing metaplane DBT expectations, up to date. I have already done that. Now if you scroll up where it says DBT packages, you will see all the dependencies that you have installed. DBT date, which is coming, with DBT expectations, and here you can see all the macros for DBT expectations. For example, utils, you can see schema tests, all these kind of things, multi-column, all the tests that they have in the documentation you can see in underneath integration tests, macros, etc, etc, right? So let's add in our model, let's add some DBT expectations data quality checks. The first DBT expectation check, I added this here underneath the models. For example, here we use the tests tag, and here we use dbt underscore expectations dot expect table column count to equal the number of columns that you expect. So in our case it would be 5, because here we have 4 columns: customer ID, then we have first name, last name, and gender. That's 4. But remember, here in our model1.sql, where we actually creating the select query, also we use the macro in the introductory video, so we have 4 columns. We create one more column here. So we expect 5 columns, and so this check should pass. And then I added 2 more checks: dbt expectations, expect column values to be between 0 and whatever here that we have for customer ID, and expect the column values to be of type big int, because here customer ID is integer, big integer actually. So if we run this dbt checks now, actually here let's, instead of 5, let's use 4, so this test will fail and those 2 other tests will pass. So let's run it again. Dbt test minus select model 1, this is what we want. Let's see. I have commented out the relationship check for referential integrity because it wasn't passing anyway. And here you will see some, okay, here dbt expectations expect column values to be between this and that, and this passed, this data quality check passed, and what else? Something should fail. Yeah, dbt expectations expect column values to be of big integer, so that was that passed this data quality check. And here for the number of columns equal, this is equals 4, so this failed. And if we check the actual SQL code for here, you will see with close, that's the compiled code, data test data and select 5 as the actual number of columns, and then we passed 4 as value, so it's checking 5 it's not equal to 4, so this dbt check, the dbt expectation check failed, right? And this is how you can use dbt expectations. There are many data quality checks to perform, and there is documentation, so everything is easy. Now let's see the dbt utils package and add some checks from there. In dbt utils I used some checks like dbt underscore utils at least one null, not null value in this first name column, or dbt utils expression is true. So here for arguments we pass the expression that first name is Kyla and where last name equals Barrett. So for example here it's like a query, we provide the expression and the where clause, and for last name I use dbt utils not an empty string, and we can also add the severity only for this column to be specified to error. So if we run this test again, dbt test minus select model 1, you will see that we added these dbt utils checks, and in the compiled code you will see the actual queries. Give it a second. As you can see now in the terminal we have this dbt utils expression is true model 1 first name for Kyla, and again not empty for last name, and you can see the compiled code here in dbt utils not an empty string, for example. And this you can see the actual SQL that we are using to validate. And here, for example, if we add one more t, this test will fail. Now before we run it again, I wanted to add in the dbt underscore project, here I would like to add the store underscore failures equals to true, that means it will create an audit table with all the errors, and actually I really like that. So let's say only run dbt util or dbt tests to run all the tests, whether it's a SQL text or the built-in tests or the checks that we created. So, and then let's move to Databricks workspace and check this audit table and see which records failed all those tests. So in your Databricks catalog, you will see this new catalog here, demo underscore dbt test underscore audit, and it will contain all the tables, and it will store the results of your tests. For example, accepted values. Here we don't have anything because everything was valid, but for the invalid records, you will see in the table, for example, this should have all these all these invalid records. For example, Tyler has duplicates here for first name, right? And you will see all these invalid records. If the table does not have records, that means everything was valid, so that's good to think. And here we have tables for each check, dbt expectations, dbt utils, the assert to nulls, the custom checks that we performed, all these kind of things. So these audit tables are very useful. And in your terminal you can see the test failures. Select from workspace dbt underscore test underscore audit, and here unique model first name, all these tables that are filled with invalid records. This is it, guys. I hope you enjoyed the video and you learned something new about testing using dbt. If you like the video, please click the like button, subscribe to the channel, leave a comment, and I will see you in the next one. Thank you.